Hi friends, today we are dealing with metal carbonyls, which is coming under the topic coordination chemistry. Coordination chemistry is a branch of chemistry which deals with the metal ligand complexes. It finds various applications in chemical and biological levels. First of all, I will say how a metal carbonyl will work. A metal which is connected to the CO group which forms metal carbonyl complexes. Look into the examples. Nickel is a metal connected to 4CO group which forms nickel tetracarbonyl and it forms the tetrahedral geometry. And another example is FeCO5. The iron metal is connected to the 5CO group which forms trigonal bipyramidal geometry. And another is CrCO6. That is, the metal here is chromium which is connected to 6CO group and it forms octahedral geometry. That is, in all examples we can see the metal which is connected to ligand. That is, here it is CO group, that is carbonyl ligand. And these three are the examples for the metal carbonyls. And coming into the homoleptic carbonyl, we can see that the metal which is connected to the same ligand forms homoleptic one, while the metal connected to different kind of ligand forms heteroleptic compounds. Next we can look how a metal carbonyl compound is formed. The metal is present and the ligand is present. Here the ligand is CO group, that is the carbonyl group. Carbonyl group is a strong pi acceptor as well as weak sigma donor ligand. Thus, by looking into this diagram, we can see that different d orbital is present on the metal and also different orbitals are present on the CO ligand. The pi orbital is present on the metal while pi star antibonding molecular orbital is present on the CO ligand. Here we can see from the CO, the filled orbital, the electrons are donated to the vacant orbitals of the metal. Thus it forms the sigma bonding. In normal cases, ligand will donate electrons to metal. But here, a back donation process is happening. That is, the filled orbital of the metal is donating electrons to the vacant orbital of the ligand. Thus, it forms a pi back donation. I already said that CO is a strong electron acceptor. Thus, the metal will donate electrons by back donation to the pi star vacant orbital of CO. Thus, in this metal carbonyl complex, we can see a sigma donation as well as pi donation. This is how a metal carbonyl compound will work. The metal orbital will nourishes the CO vacant orbital, while the filled orbital of the CO ligand will nourishes the vacant orbital of the metal. Thus, the both metal and the ligand nourishes each other. Thus, this type of bonding is known as the synergic bonding, in which the metal get the electrons by sigma donation and the ligand get the electrons by the pi back donation process. And next, I am saying that few applications of coordination chemistry. These metal carbonyls are examples of coordination chemistry. For example, I am saying for checking the hardness of water, we usually take a ligand, that is EDTA, which is also coming under the complexometric titration. There are two types of hardness are present, like permanent and temporary hardness. Here we are mainly focusing on the temporary hardness, which is found by the presence of metals, calcium and magnesium. When it is titrated against the EDTA, we can find how much hardness is present in that water. Like that way, we can find hardness of water using the coordination complex. And next application of coordination complexes is about the catalytic process. It's named as the Wilkinson catalyst. That is PPH3 thrice RHCl, tris triphenyl phosphine rhodium chloride. It will act as a Wilkinson catalyst and used for the catalytic process for the hydrogenation reactions. And another application is in the bioinorganic level. That is, the coordination complexes can be also used in the biological levels. Such as in plants, we can see chlorophyll. So, the chlorophyll is mainly a coordination complex in which the metal atom present in it is magnesium. And in hemoglobin, that is our blood, contains iron as the metal atom. And the vitamin B12 contains cobalt as the metal atom. And these three complexes forms the biological pigments and also forms the coordination complexes. Thus, there are variety of applications of coordination chemistry in biological and chemical industrial levels. And remember that the cobalt in vitamin B12 is the only vitamin which contains metal. And this is a video about the metal carbonyls. Hope you understand it. Thank you for listening to me and have a nice day.